Hello, curious minds, welcome to the wonders of the solar system. In this series, we'll explore the incredible celestial bodies that make up our cosmic neighborhood. If you enjoyed our video, how long would you survive on the planets of our solar system? You're in for a treat as we dive deeper into the mysteries of each planet. Today we'll kick things off with the closest planet to the Sun, Mercury. Mercury formed about 4.5 billion years ago when gravity pulled swirling gas and dust together to form this small planet nearest the Sun. Like its fellow terrestrial planets, Mercury has a central core, a rocky mantle, and a solid crust. It is the smallest planet in our solar system, without any moons, and the second densest planet after Earth. Mercury is a rocky world with a diameter of about 4,880 kilometers, making it just slightly larger than Earth's moon, or little more than one-third the width of Earth. To put this into perspective, if Earth were the size of a nickel, Mercury would be about as big as a blueberry. Its average distance from the Sun is about 58 million kilometers, 36 million miles, or 0.4 astronomical units. 1 astronomical unit is the distance from the Sun to Earth, which is about 149 million kilometers, 93 million miles. So from this distance it takes sunlight 3.2 minutes to travel from the Sun to Mercury. Here's a fascinating detail. Because of this close distance to the Sun, our star would appear more than 3 times larger in the sky of Mercury than it does from Earth. Mercury is named after the Roman messenger god, and for a good reason. It zips around the Sun faster than any other planet. Its egg-shaped orbit takes the planet as close as 47 million kilometers, 29 million miles, and as far as 70 million kilometers, 43 million miles, from the Sun. It only takes Mercury 88 Earth days to complete one orbit, traveling through space at nearly 47 kilometers, 29 miles per second. That means a year on Mercury is shorter than 3 months on Earth. But there's a catch. Mercury's rotation is super slow. It takes 59 Earth days for Mercury to spin once on its axis. Because of its fast elliptical orbit around the Sun, things get a bit strange. When Mercury is closest to the Sun appears to rise, set, and then rise again in some places. At sunset, the opposite happens. The Sun sets, rises briefly, and sets again in other places. Because of this weird spin-orbit dance, a full day on Mercury from sunrise to sunrise lasts a whopping 176 Earth days, which is just over 2 Mercury years. Talk about a long day. Another interesting fact is that Mercury's axis of rotation is tilted only about 2 degrees compared to its orbit around the Sun. This means it spins almost perfectly upright and doesn't experience seasons like many other planets do. Now, for a moment, imagine standing on the surface of Mercury. What would it be like? Well, for starters, you'd need a serious heat shield. During the day, the surface temperature can soar to a scorching 800 degrees Fahrenheit or 430 degrees Celsius. That's hot enough to melt lead. But here's the crazy part. At night, the temperature plummets to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. That's because Mercury has a very thin atmosphere, which means it can't trap heat. So Mercury experiences the most extreme temperature swings of any planet in our solar system. Looking at pictures of Mercury, you'll notice one thing right away. Craters everywhere. Like our moon, Mercury has been bombarded by asteroids and comets throughout its history, leaving its surface pockmarked with craters of all shapes and sizes. Some of these craters are relatively small, while others span hundreds of miles across. The constant barrage of impacts has created a rugged and uneven landscape that is both fascinating and haunting. But Mercury's surface isn't just craters, it also has vast smooth plains, kind of like the lunar Moriah on our moon. These plains are areas where the surface is relatively flat and free of large craters. They provide a stark contrast to the heavily cratered regions and offer clues about the planet's geological past. These plains were likely formed by volcanic eruptions billions of years ago. When Mercury was still geologically active, molten rock from the planet's interior would have erupted onto the surface, filling in low-lying areas and creating these smooth plains. Over time, the volcanic activity subsided, leaving behind these expansive, flat regions. One of the most striking features on Mercury is the Caloris Basin, a giant impact crater over 900 miles or 1,500 kilometers wide. This massive crater is one of the largest impact basins in the solar system and serves as a reminder of the powerful forces that have shaped Mercury's surface. That's like a crater the size of Texas. The impact that created the Caloris Basin was so powerful that it sent shockwaves around the entire planet. These shockwaves caused seismic activity and created a series of concentric rings and fractures that can still be seen today. The Caloris Basin is a window into the violent past of Mercury, and a key feature for scientists studying the planet's history. For a long time, scientists were puzzled by Mercury's magnetic field. It's a tiny planet, and they didn't think it should have a magnetic field at all, but it does, and it's actually quite strong. Thanks to data from the Messenger spacecraft, we now know that Mercury has a massive iron core. In fact, the core makes up about 85% of the planet's radius. That's huge. The core is partially molten, and its movement generates the magnetic field. It's like a giant dynamo deep inside the planet. Interestingly, Mercury's magnetic field is not centered on its equator. Although it's only about 1% as strong as Earth's magnetic field, it interacts with the solar wind in fascinating ways. This interaction can sometimes create intense magnetic disturbances, almost like magnetic tornadoes, which direct the fast-moving solar wind plasma toward the planet's surface. When these charged particles hit Mercury's surface, they knock off neutral atoms and send them spiraling high into the atmosphere. Now let's talk about space missions. NASA's Messenger was launched on August 3, 2004. It embarked on a complex journey including flybys of Earth, Venus, and Mercury itself, to enter orbit around Mercury. The mission's primary goals were to understand Mercury's geological history, map its surface composition, study its magnetic field, and investigate its exosphere. In 2011, Messenger made history by becoming the first probe to orbit Mercury. Over the next 4 years, it provided unprecedented data, transforming our knowledge of this elusive world. Among its key findings, Messenger confirmed the presence of water ice in permanently shadowed craters at Mercury's poles. It also mapped the planet's surface in remarkable detail, uncovering its rich composition, including unexpected amounts of volatile elements like sulfur. The spacecraft provided in-depth information about Mercury's magnetic field and its interaction with the solar wind. Additionally, Messenger revealed large cliffs, or scarps, on the planet's surface, which are believed to be the result of Mercury's cooling and shrinking over time. The mission ended in 2015 when Messenger, low on fuel, crashed into Mercury's surface. But the data it collected continues to provide valuable insights into this enigmatic world. The exploration of Mercury continues. In 2018, the European Space Agency and the Japan Aerospace Exploration Agency launched the BepiColombo mission. BepiColombo consists of 2 spacecraft, Mercury Planetary Orbiter and Mercury Magnetospheric Orbiter. They are scheduled to enter Mercury's orbit together in December 2025. The MPO will focus on studying Mercury's surface and internal structure, while the MMO will investigate the planet's magnetic field and its interaction with the solar wind. BepiColombo aims to provide even greater detail than the Messenger mission, further unraveling Mercury's mysteries. The mission is named after Giuseppe, or BepiColombo, an Italian scientist who made significant contributions to our understanding of Mercury's orbit. Even with all we've learned from Messenger and BepiColombo, Mercury still holds many mysteries. One of the most intriguing findings from Messenger was the discovery of hollows, shallow, bright depressions on Mercury's surface. These unique features are unlike anything found on other planets. Scientists think they might form through sublimation, where intense heat causes solid materials to turn into gas, leaving behind these peculiar pits. But this theory is still under investigation. Another mystery is the presence of water ice in permanently shadowed craters at Mercury's poles. This was surprising because, despite Mercury's proximity to the sun and extreme daytime temperatures, some craters are so cold, down to -173 degrees Celsius, that they can trap and preserve ice for potentially millions of years. This discovery offers fascinating clues about the history of water in our solar system. As BepiColombo continues its mission, it aims to uncover more about these mysteries. With its advanced instruments, the spacecraft will provide deeper insights into Mercury's surface and composition. Each new finding helps us understand not only Mercury but also the formation and evolution of our solar system. As we continue to explore our solar system, Mercury remains a high priority for future missions. Scientists are eager to learn more about its internal structure, its magnetic field, the composition of its surface, and the mysteries of its hollows and water ice. Future missions could include landers that could study the surface up close, rovers that could explore vast distances, and even sample return missions that could bring pieces of Mercury back to Earth for analysis. Mercury may be the smallest planet in our solar system, but it holds a wealth of secrets waiting to be uncovered. From its extreme temperatures to its fascinating geological features, Mercury truly is a wonder of the solar system. What do you find most fascinating about Mercury? Is it its scorching daytime temperatures, its mysterious magnetic field, or something else? Let us know in the comments below. Thank you for joining us on this journey. Be sure to subscribe and hit the bell icon so you don't miss our next episode, where we'll dive into the mysteries of Venus. Until next time, keep looking up.